we were doing the different methods of determination of reaction mechanism. We have done already 3 methods. Next, fourth is isotopic effect. In this, mainly we are emphasizing on the breaking of bond which involves the presence of isotope. If the bond involving isotope breaks in the rate determining step, then only the effect takes place or the reaction slows down, otherwise not. So the isotopic effect is mainly based on the breaking of the bond in which isotope is present. That is, we can say, and thus the difference in the rate of reaction due to the presence of different isotopes in the reactants is called isotopic effect. That is, if there is a difference in the rate of reaction due to the presence of different isotopes in the reactants is called isotopic effect. If there is no difference in the rate of reaction due to the presence of isotope, then it is not an isotopic effect. If there is a difference, first without presence of isotope and second with presence of isotope, then we say it has isotopic effect. Isotopic effect is of 2 types: primary isotopic effect and secondary isotopic effect. Primary isotopic effect means the bond involving the isotope is being broken in the rate determining step, then we say it is a primary isotope effect. If the bond involved in second is secondary isotope effect. When the bond involving the isotope is broken in non-rate determining step, then we say it is a secondary isotope effect. That is, if the bond which involves isotope breaks in rate determining step, then it is a primary isotope effect, otherwise it is a secondary isotope effect. And taking up example of isotopic effect is nitration of benzene. In nitration of benzene, as we have already done in earlier method also, nitronium ion is a intermediate which attacks the benzene, and then the reaction takes place in 2 steps after attacking. That is, nitronium ion when attacks benzene, then we get different carbocations which are resonance stabilized. That is, these carbocation are formed, and this reaction is a slow step. So when this bisulfate ion it reacts with this, then this hydrogen is abstracted and these electrons come back to the ring, and so we get this nitrobenzene and sulfuric acid H2SO4. So in this reaction of nitration of benzene, in which first nitronium ion attacks benzene and then this carbocation is formed, then this stabilized carbocation reacts with bisulfate ion to give nitrobenzene. In this reaction, if we suppose we use benzene with labeled hydrogen, that is, hydrogen is replaced with deuterium, when this benzene is used, then this reaction do not affects the rate determining step. That is, no hydrogen bond is broken when nitronium ion attacks this. Therefore, this reaction has no meaning whether hydrogens are present or deuterium is present. So the reaction is not slowed down when deuterated benzene is used. This indicates that this reaction is not the reaction in which this bond, that is this bond breaks, is not a rate determining step. That is, we can say when deuterium labeled benzene is used, then the rate of reaction remains the same, that it has no effect of deuterium, as in simple benzene. It indicates that second step involving breaking of CH bond, in CH bond is breaking in the second step only. So this is not a rate determining step, and so first step is rate determining step. So we can easily determine by isotopic effect that the reaction which involves the breaking of carbon and deuterium or carbon and isotope is a rate determining step or it is not. So next is kinetic studies. Kinetic studies helps to determine rate law and the order of a reaction, as we have done earlier in lower classes also. So it determines the rate law and the order of a reaction. In a rate law, that is the how many reactants are involved in a reaction in a rate determining step. So by comparing the experimentally observed rate law with the theoretically derived rate law, it is possible to find whether the proposed mechanism is acceptable or not. So in this we compare experimentally observed rate law and the theoretical derived rate law, and it is possible to know whether the proposed mechanism is acceptable or not. The mechanism we are proposing is acceptable or not, is the correct or not. As we can see in this example, a reaction between tertiary butyl bromide and hydroxide. Example, in reaction between tertiary butyl bromide and hydroxide ion, it follows first order kinetics. It orders first order kinetics. That is, in this in the rate determining step, only one reactant is involved. So in this first, that is in this reaction, that is in tertiary butyl bromide, when it is treated with OH negative hydroxide ion, it forms this alcohol. In this, Br is replaced with OH group. So we get this product, and in this the rate determining step is this rate determining step is independent upon only one reactant, this, but here there are two reactants, so it means this reaction is taking place in a number of steps, and the one step in which only one reactant is involved, that is the rate determining step. So it gives the evidence that the reaction follows SN1 reaction mechanism and takes place in two steps, and the rate determining step only involves one reactant. This we can see here, that is, first this halide forms this carbocation plus bromide, and this carbocation is a stable carbocation as it is a tertiary carbocation, and this step is slow step, and slow step is a rate determining step. And in the second step, this carbocation reacts with OH negative, and this reaction is fast and it gives the alcohol. So the reaction actually takes place in two steps now, and the first step, which involves only one reactant, is a slow and it is a rate determining step. So we can easily understand that this reaction is taking place in two steps or in a number of steps, and the reaction involving one reactant only is a slow step, is a rate determining step. So in this way, chemical kinetics helps to determine what will be the reaction mechanism, what type of reaction mechanism is there, how many steps are taking place in a mechanism, and in a rate determining step, that is slowest step, how many reactants are involved. So next is stereochemical evidence. The stereochemical evidence, it is generally involves reactions in which chiral molecules are present, and it gives information about the chiral molecules mainly, and the reaction occurs by SN2 and follows second order kinetics can be shown by suppose we have a reaction, that is 2-bromooctane reacts with aqueous KOH to form 2-octanol. Now in this reaction, what will be the reaction mechanism, then what the final product has stereochemistry, it all can be explained. In this reaction proceeds with inversion of configuration, and it means that reaction must proceed or follow SN2 reaction mechanism, because in SN2 only the inverted products are formed. That is, this is a halide. We have taken bromo-octane, and OH negative then attacks from the side opposite to the side from where halogen is attached, and this attacks from left side. Then we get this transition state, and then we get this product, which is inverted product, in which there should be one negative charge only, in which OH is present on the left side and Br was present on the right side. So we get the inverted product. In the final product, OH cannot occupy the same position as by Br. This cannot occupy the same position as Br. So if proposed mechanism is correct, the reaction must proceed by inversion of configuration. Inversion of configuration means the reaction must be following ascent by stereochemistry, stereochemical evidences that which mechanism will be followed by which type of reactions. So, and thus that is 2-bromo-octane reacts with aqueous KOH to form this, and this if proceeds by inversion of configuration, it means it follows SN2 reaction mechanism, in which first reactants react to give this transition state, and then it gives the inverted product. And in this, OH cannot have the same position as the Br, so we get the inverted product, which follows the SN2 reaction mechanism. So methods to determine the reaction mechanisms, and now we will start with next chapter in the next lecture.